So this is about the domain of a composite function. So what is the domain of f after g? Well, that will be the domain of g intersection the set of all x's such that g of x is the domain in the domain of f. Okay, so how to remember this? Well, it's just don't memorize, because memorizing is never good. Aim for understanding, and understanding is the easiest if you imagine the actual process of. So what is f after g? What is that? Well, we have the function g. Okay, this is function g, and you know that x goes in. So what sort of x can go in there? Well, it's like, well, that's by definition of the domain of g, all the allowed inputs for function g. Okay, so when we have the composite one, well, it certainly, they can only be just the elements coming from the elements of domain of g, because first we need to feed it into g. Okay, so now g of x comes out, and in the function composition what we have is that, because this is f after g, so we really do f after that, so g of x goes in. Well, you see, it's we need to make sure that g of x is actually an allowed input for f. So we can only choose those values in the domain of g such that whatever g of x is, whatever g produces, it's actually an admissible input to f. Okay, and it's what comes out is, of course, f of g of x, and this whole thing is f after g. Okay, so it's very important to go through this and check this, because for numerical functions it's often it could be deceiving. So if you just, while you calculate what would be f of g of x, calculate in general, and you look at it, oh, what's the domain of this expression? Well, but that expression simplified may forget about that, oh, we have actually a composition here. The value should go through g first, then f after that. Okay, so this is basically just the set theoretical description, what is written here, of this image. And I think this image is actually not too difficult to remember. That's just, we are doing a composite function, we do f after g.